Hey everybody, welcome back to Global Conflict TCG. So this is going to be like my third take for devlog number 4, so here we go. Hopefully this one flies. um, Alright, so since my third devlog, I've done quite a bit of work to the startup manager. I've actually went ahead and added the prize feature already, and I added a panel, a pop-up panel for the mulligans, so the player can choose if they want to draw cards or not. Um, so the reason I actually did like film while going through the process of making these systems, but as always, like I ran into just a bunch of snags and a bunch of different problems along the way. So um, instead of you guys, watching me for an hour and a half try to figure these things out, it might just be better for some, if I can, try to go along the way. I'll try to show you, but sometimes I'll probably have to circle back and just like do the devlog and just show the progress I've made once it's all like completed, and I'll explain it. And then once it kind of helps too, because um, I'll probably have like a lot better understanding of what I actually did. So okay, so let's go back. So devlog 3, we went through the mulligan system, and if you remember, basically we set the a mulligan variable for player 2, and we would do an int compare, and depending on if it was equal or if player 2 had a higher int value for mulligans, then we would go to an action where we would draw cards for each mulligan that they had more than us as player 1. Worked great. So what I did was I actually created a panel. Let's see. So let's go to the actions first. So this whole thing right here, this is all of these states are actually all of these have to do with the mulligan system. And so if we go here, start, state number 8, we can see that our mulligan system, we're getting the FSM int, doing the compare, subtracting the two ints, and then activating a game object. So this is the choice panel. So this is a new state that wasn't in my last video. So this state here, essentially what it does, it just activates this game object, which is up here in the hierarchy, player 1 mulligan choice panel. And you're going to see that here in a sec. So that we activate this game object. Once this object is activated, we in turn we are checking the FSM bool, check FSM bool. So on the back end, if we go into the choice panel, we could see we have a button here, a yes button and a no button. Each of those buttons have FSMs attached to them, and if I open it up, you can see here, it's really just this first state with an on-click event, setting the bool value. So essentially all that means is when we click the button, it'll change the bool value from false to true. That's it. It's not sending anything else. I gotta actually get rid of all these states because they're not needed. Same thing with the no button. So if we go back, we are pulling these FSMs in both for the yes button and the no button. And then at the same time, we're going to check the bool or do a bool test for the yes button and the no button. And we're just looking to see if they're true. So by default, they're both going to be false. And depending on what the user clicks, yes or no, one of these will turn to true. And when they do, you could say here on the states, we have different events. So player 1 says yes, then we're going to go ahead and start our drawing process and draw cards from the deck. If they say no, then we're just going to go ahead and finish. We'll deactivate the panel, and then we'll go ahead and continue on to draw our prize cards. So that's how that works. It's just, this state is literally like, this state will stay live until the user selects yes or no. And then of course, if there's no mulligans, then this entire process will be bypassed here. If the mulligan count is equal, or we don't, they have less than us, then it'll just proceed. So there's that. We'll probably have to add like another like state in here that just tells us after, say like if our opponent has mulligans to draw, like cards to draw, then we'll have to have like another check to tell us when they're done. We'll do that another time, but it's going to be really simple. It's going to be another bool variable that gets checked. And then what we'll have to do is have that kind of like in here somewhere where we're just going to do a check before we proceed and start drawing our prize cards. So no big deal. I'll do that on another video, but yeah, so this works. And then of course down here, I changed this action again. So I'm using array get next, start index of 0, and then end index of player 2 mulligan count. I went this route, so it'll take that int variable that we subtracted from, and then it'll run through that index on the array. So it works pretty good. Nothing has changed there. I did run into an issue though. Initially when I had set this up, I ran into an issue where if I drew more than 3 cards on a mulligan turn, what was crazy, it would draw the 3 cards into my hand, but then when it would go to draw the prize cards, it would, instead of drawing 6 cards, it would actually stop at 5. And it did it every single time that I would draw more than 2 mulligan cards. So it was like really throwing me off, and spent a pretty good amount of time just trying to figure it out. But what I ended up coming up with, and it's actually a really good like learning lesson about Playmaker, and more specifically arrays. Let's take a look at state number 5. This was actually the problem. So state 5, initially I had it set up as an array get next, no loop, and the way I had it set up was array get next, start index of 0, end index of 6, and that worked great. Like it was totally fine. But the problem is when you use array get next and you set the end index of 6, right? The problem was if I drew too many cards from the mulligan, the length of the player 1 array, of the player 1 deck array, would actually be less than the end index of 6 stated here in the array get next action. And essentially what that tells me is that this action will look at the array. Every loop, it'll take a new snapshot of the array, and if you don't have enough items in the array to meet the end index criteria, it'll stop the get next action. And so that's what was happening. It would basically, I didn't have enough cards in my array to support this array get next. Even though technically I did have enough cards, but the length or the amount of objects in the array didn't support that number. So I essentially had to stop using this action because it didn't matter. Even if I changed it to 6 loops, it didn't matter. So what I did instead, and I could actually just go ahead and remove it. I switched to array get. So, just take the next out of it. And what's cool about array get is that if we go ahead and highlight it here, it tells us get a value, add an index. Index must be between 0 and the number of items, -1. First item in the index is 0. So essentially all this action is doing, you're just telling it which item to get in the array, and and the way you do that is just tell it which number on the index you want. So it's kind of the same as array get next, where array get next, all it does is it gets you index number 0 every single loop. So this is just a different way of doing it, where I'm telling it, get me index number 0, store it as a prize card, and then I just put the loop action for 6. And so this way, this action is not looking for that 0 to 6 index. It's just looking to it just looks at index 0, which I told it to look at, and that's it. It doesn't look at the rest of the array. So that's perfect. And on top of that, it has an index out of range. So say if we were to run out of cards in our deck, I can actually add an event that will take me to another state saying something along the lines of like, you know, no more cards in deck or something. Which actually, this is going to come in handy when we get to the turn manager and we have to start looking for win conditions, because we're going to look at the array, and if there's nothing there, then that's a win condition for the other player. So yeah, this is a really good learning lesson, and I think I'm going to start using array get with the loop action in place of array get next, probably going forward, just because I think it's a lot more reliable. So enough of me yapping. Take a look. We're on play maximize. You'll see what I'm talking about. So when I click play, we're going to draw 7 cards. I have an int value set up for player 2 having 5 mulligans. So we're going to get some extra cards to draw at some point, just depending on how many times we mulligan. So let's hit play and go. All right, 1, 2, 3. It looks like we have no mulligans. So here's our panel popped up. Your opponent's unable to draw a basic unit on one or multiple draws. You can draw 1 card each time your opponent had a mulligan. Would you like to draw? And then this was a text mesh pro, just text box, all it is. Plugging in the mulligan int value. So it says 5 mulligans, which is correct. And so at this point, I could select yes or no. So if I want to draw the cards, I'll click yes. If not, I'll click no. I am going to go ahead and click yes. And it's kind of hard to see, but here are all the cards. So that was 5 plus 7. That equals 12 cards. And then we can see here our 6 prize cards have loaded. So here they are. And then we only have 2 cards remaining in the deck. So perfect. It worked out. Exactly what I wanted to do. So that's pretty much what I've been working on. Let me go. There's a couple things I want to just kind of point out before I get off of this video. Like I said, I'm making these videos for a couple reasons. Number one, just to put the information out there on how to do like this kind of game, because I looked all over the place trying to find videos to make a card game like this, like Pokemon in a way, and they're just not out there. So I hope this helps somebody down the road. But number two, it also helps me out to kind of teach it as I go, and ends up sinking into my brain a lot better. So yeah, so let's go back to the mulligan choice panel. Let's fire it up. Here it is. Let's take a look at some of the objects. So we have a text box here. Actually, let me zoom out. There we go. Text box there. You got the yes button. And one thing to note, these buttons are really simple, but when you create the FSM like this, you do have to set the on-click event, and then on the on-click for the button itself in the inspector, right here in the upper right corner where my mouse is at, you're going to have to add an event. And then when you do that, you're going to take this Playmaker FSM, you're going to hold it and drag it into this box. And then it'll pop up there, and then you can just put the event string. So you got to type it in the same on-click event here, and then change this to send event string. So that's how I did that. It's really simple. Once you do it once, you'll know how to do it forever. And then the mulligan counter is also really simple. Here is an FSM that's attached to it. I don't know. I had put the wrong FSM, so I'm just going to remove this one. All you need, get FSM int. So this is going to get the int value of a variable from an FSM that I specify. So that int, I actually have to go, even though it's for player 2, I have to get the subtracted value int that we run through our startup manager. So we go to the P1 startup manager, go to P1 startup manager FSM. We get the variable name P2 mulligan count. We store the value mulligan count int. And then from there, we just set the text mesh pro text. That's all it is. And so all we do with the text, the game object is user owner, and it's this variable P2 mulligan count int. And when you put this in, you actually have to convert it. So you see here in the panel, it's going to convert. It's because this value is an integer, and so we're going to convert it to a string, so that way it actually pops up in the text box. That's all that means. So that's all I did for that, and I just kind of shoved it in here in the text. It doesn't look the greatest, but it works. But that's all I did for that. And then one other thing I want to talk about too. Not one other thing, but actually, let's cover this. How did I do the prize cards? That's the next thing. So let's go back, because I haven't even talked about that yet. So the prize cards, I'm using array get, like I talked about. Set the index to 0, loop it 6 times, easy. When we do that, the first step that we're going to do is a find child. Find child from the repository. We're going to save that. We're going to look for the prize card from array, and then we're going to store that as prize card from repository. We're going to enable, or in fact, we have this action called enable FSM, but in fact, what it is doing is disabling an FSM on the card that we draw from the repository. This is important because you don't want, show you, when the card comes in here to the prize card section, we don't want the card to sit there and to be draggable still. We want it to be stuck there, and you don't want the player to be able to drag that prize card around, right? So to do that, we just go ahead and disable the drag and drop FSM that I have on every single card prefab. So we just uncheck the box enable, and then it disables that FSM, and then effectively those cards are stuck there. At the same time, we also set the parent to the prize card section, so that way it spawns here. Reset the relocation. We're going to get the child of that same card that we set there. We're going to get the child. Specific child object name is card back. So if you look at my card prefabs, like this one, let's go and open it up. You could see here these prefabs are actually pretty intensive. There are a lot of different objects I have here, like the glow ring that when you hover your mouse over, unit card image, damage counter box, unit attachment box, ammo counter at the bottom. So there's a lot of pieces to this card. It's actually pretty intense how much is going on each of these prefabs. But here's the card back. This one is disabled by default, and so this is meant to hide the card. So like when it's in the prize card section, you don't want the player to be able to see it, so we just flash up the card back, and now you can't see it. So that's how I do that. And so essentially, if we go back right here, get child, get card back, save that as a variable, and then we're going to activate the game object child card back, and activate it, and then that'll cover the card so you can't see it. So kind of a tricky way of doing that. And then from there, we're going to go ahead and store, we're going to remove that same card from the array, so that way our count is accurate. We'll wait 3.3 seconds, and then we'll loop again, do it again, do that 6 times. That'll fill our prize card slot, and then once that's done, we go to this empty state, which I haven't done anything yet. So that's it. That's where I'm at so far. Looks like we have one error. I don't know what's going on here. We triggered something. 2D event. Oh, it's just saying it requires a prefab. I was tinkering around with something earlier, but yeah, so that's it for that. So we set up the prize cards, we set up the mulligan system, we have a flash panel so the player can make a choice, and that's it. I'll show it to you guys one more time just so you can see what's going on. Go on maximize. Here we go. We draw our 7 cards. Looks like we do have a basic. Do we want to draw a mulligan, 5 mulligans? We can say yes, but I'm going to show you the no side this time, so let's go and click no. And then there we go. Wait a couple seconds, and then we'll go ahead and fill our prize cards. And it's perfect. So yeah, we got, remember, I only have 20 cards in the deck, so 6 plus 7 is 13, plus another 7 in our hand equals 20. So our counts are accurate, and they're working great. We'll go ahead and fire it up one more time. We'll see if we get any mulligans this time. 1, 2, 3. Yep, 1 mulligan for us. 2 mulligans for us. And now we have a basic. So it's 5 from player 2 minus 2 from us. So 3 total mulligans. Yes, we'll go ahead and take it. There we go. So we should have 10 cards in hand. 6 cards in the prizes, 4 cards in the deck, and it's perfect. So mission accomplished. Another good day of devlogging, another good day of working on this game. It's all working. It's all coming to plan. It takes quite a few steps, but we're figuring it out as we go. So that's it for that. Hope you guys enjoyed it. Hope you guys have been following along with the devlogs. If you have any questions, hit me up in the comments. I'm always monitoring that stuff. But otherwise, we'll see you on the next devlog as I keep working on this. Look for devlog 5. It'll pop up on the screen here somewhere once I actually get to it and load it back to this video. So see you guys on the next one.